Cuidado, because I was stuck.
Yeah, I got one. Okay, because when I first saw that, I got the version that was like 55 cents. It's like C, delta P, H. Just didn't worry about the LA. So forgot about that. Super go. I got points off. Sure, those points. I think those bonus points are
You will be ready in 5 seconds, right? Okay, now it's 11. Let's start. We talk about heater treater. Okay. Today you will later have homework, and next Wednesday you have some senior design presentation, right? So this homework, this coming homework that you expect sometime today, we will have the deadline after the senior design, so that you have time to do it. Is that good? Okay. Senior design for presentation for next Wednesday. So already we know class, so we still have to have a class. So we talk about gravity separation. This gravity separation and more gravity separation. Look at the equation. The equation is, we talked last time about this equation, right? But I didn't show you any derivation. This equation is very similar to the two-phase separator equation when we derive it. Okay? So if you have to do more calculation about heater treater, you can use this equation. And the way that they come up with the equation, the concept is the same compared to settling time. Question. Yes, question.
Is this in the slides that I already had? Yeah. Oh, got it, found it.
Yes, this is in the slide that we already have.
Got it.
Okay. We actually talk about this, right? Talk about this. That one too, for free water knockout. And we talk about loose emulsion, free water layer, moderate emulsion, tight emulsion to select C factor. You will do this in the homework. So you select the C factor from here, then go back to treater equation to find out how big is the treater you should use. Okay. In addition to this, you can do with the graph method. And we talk about it a little bit. So graph method, you start with select the specific gravity of water. Okay. Then go up to the specific gravity of oil. Turn right to find treating temperature, this part. And then you go up to find, okay, do you have a loose emulsion, moderate emulsion, or tight emulsion? Okay. You have sign-up sheet? Where is it? Just circulate it around for the sign-up sheet. And then we go to the size of the tank to select the oil capacity. So different size of the tank tell us reach this point, then go up and find out, okay, what is the oil capacity that the heater treater can handle. Just use the chart, or you can use the equation. Should be the same answer. Okay. And you will get more experience on how to use the chart in the homework. Okay. Retention time calculation 1440. Everyone know how to derive this? Yes or no? Not exactly. We talk about it. Did we talk about it? Yes. 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 Right. Chris, what's your last name? Where's another Chris? Oh, okay. Two Chris's here. Okay. We talk about how to get 1440. Did I? Come on. Ernest? Marisa? No, did not? Kelly? Did I? No. How come? $24 times 60. So it's just like volumetric flow rate equal to volumetric flow rate W, right? Equal to volume divided by retention time. Okay, just volume divided by retention time. And we change the unit to match. Instead of time is day, so 1 day has that much minute, I think. Do you think so? Probably. 60 multiplied by 24, so about 24. So you get 1440. 60 multiplied by 24. Okay, that's we talked about already. Retention time in the treater gun barrel. So this is a suggested retention time. How much should that be? If you go back to use that equation, make sure that the unit is consistent. And the part that I point out is for free water knockout, you can use less retention time but has to heat more. We talked about this, right? Yes, we did. And apex gravity and retention time for gas liquid separator. Three-phase separator, you have seen this in the lab. You know where's the water bucket, oil bucket, gas settling section, inlet diverter, like that name. If I just point at that point and I don't give the name, you should be able to tell it. Okay, that LC, oil level control, liquid level control. You know all that, right? Pressure relief valve. That is in the lab. And this equation, isn't it in the lab? You get a handout from the lab that has this equation, right? Yep. So left side has oil and water. Right side has just water. Which side is taller? Left side. How much taller? You know how to calculate, right? This concept is the same concept in this part. In the gun barrel, we still use this concept. So this time, right side is oil and water, and plus some pressure from gas. And left side is just water lake. Okay. But pressure from gas from here go into oil water layer and also go into that water layer. So it doesn't matter for if you consider that gas or not, because the pressure from gas go to both sides. It's just push everything down. So everything get the same effect of that. So the left side, so you have liquid height, right? Right side, you have oil height and water height. This thing is for the gun barrel. In the gun barrel, what you do is you have production fluid come here, and then gas go on top, liquid or emulsion go down and go to the spreader. This plate spread everything out. Okay, this is what inside the gun barrel, the big one that you see at Chevron Yard. So go inside. The equation on the left that we have here is just to tell you how do we do the setting on the height inside. So if you want this height to go down, then you you cannot make it go down that much. Then you reduce the adjustable part here. Okay, go down. Then you will have the liquid height inside to be lower. If you want to increase the liquid height, you move it up. Okay, so you kind of increase the static head. You have seen it, right, in the Chevron yard. This was in the exam last year and 2 years ago, but I think it's too easy. You know this already. So, okay, gun barrel without heat and gun barrel with direct heater. So without heat, you can have gun barrel without heat. So for the case of loose emulsion, use gravity to separate it. So oil inlet should be about 80 or more. Then you don't need any heat. Alright, the next one is gun barrel with direct heater. So you can have heat for the gun barrel. So use for sweet, not much corrosive oil, and have loose or moderate and tight emulsion. For the case that you have very corrosive, Silvas also sell you indirect heater. Okay, so this is for all gravity oil, normally for loose, moderate emulsion. You may have scaling over the heating surface. Okay, and there's a gun barrel tank with steam generator. This comes from Silvas textbook, so they also sell you with steam generator. So for very corrosive emulsion, you cannot have a heating element to touch with the corrosive fluid, right? So it has to be indirect heater. So, so this is for tight emulsion where higher heating temperature are required to obtain with indirect heater. So there are two kinds of indirect heater. If you want indirect heater but a lot of heat, we use steam generator. If we just have a sweet crude, we don't use any indirect. And if it is hot already, we don't even do any heating. If you go through heater treater already in your gun barrel, you don't need to heat at all. Okay? So this is the case where you don't want to put heater treater and put everything in gun barrel. But if you have heater treater before, then you don't do any heat in gun barrel. It will be already hot. And in the tank battery, they heat it to match the read vapor pressure 9 psi at 100 F. You remember this number? It should be somewhere in the test. Okay. So gun barrel tank size, see the tank size, capacity, nominal capacity, volume, barrel per feet, okay, and the weight. So that's a available size. And for gun barrel, you can size it, use a chart. Just another chart for gun barrel. So you do the same thing, start with a specific gravity of water, whatever it is. Stop at the line that tells you the gravity of oil, and then move to the right side. Treating temperature, how much we want to treat, or what is the temperature. Then you go up to what type of emulsion. Go to the right, and wherever you stop, this will tell you so you stop at a certain size of gun barrel, and the top part will tell you how many barrels, okay, how many barrels per day that gun barrel can treat. So look at that. It can do 8,000, 10,000 barrels per day of water per day. So if you look at another chart, the previous one, the treater can do just 4,000. So if you have a lot of capacity but not much tight emulsion, you may just use gun barrel. So when you use gun barrel, you have more retention time. You don't have to heat that much. Or if you want the gun barrel to just do the separation after it's already hot, like the second stage of separation, you have heater treater. Steam generator, this is how it looks like. Equation for steam generator. Steam generator, we connect it with the coil in the tank, right? So it's indirect heater. When it's indirect heater, you heat steam and use steam to heat water or liquid inside the tank, inside the gun barrel. The good thing with temperature of steam is this. Look at this one, 250, maximum for low pressure is 15 psi steam. If we use just water can do just 180, 190, right? But not 250. So if we do steam, we can do hotter. Okay? So this is for tight emulsion that require more heat, more retention time, and corrosive. If it is not corrosive, just use heater treater. Okay? Because do indirect heating, the name suggests, right? It's indirect. It's not as efficient as direct heating. Okay? And you do it the same way that you did earlier. This time, we don't use that 10,000 BTU something. We use 67.5 BTU per hour per square feet per Kelvin per Fahrenheit. So this is the expected or average value for the U value. You do the same thing that you did earlier, okay, to get the area, coil area. Okay. Look at the unit. When it is BTU per hour, this is equivalent to watt, right? Per square foot, per Fahrenheit. So that is the unit of overall film coefficient or overall heat transfer coefficient. That much, that thing. So that's the average. And then TD is just the temperature difference, okay, in degree Fahrenheit. So that is the same method that you use for indirect heater or line heater. Okay, that's for steam generator in the gun barrel. Quantity of steam required. Quantity of okay, quantity not quality. So quantity is W power per hour equal to heat required BTU per hour divided by latent heat transfer of steam for temperature use. So for if you use BTU per power, then you want to use the latent heat of 945 for 15 psi and 250 F stream. If you use something else, have to open the manufacturer or CWAS book to see what it is. Okay, so with this, you will be able to find how many pounds of steam do you need to generate, okay, that to be used to heat that very tight emulsion and corrosive fluid, okay, and that will be, this will use to calculate the heat generation. After you know how many pounds per hour, then you know we heat steam from what temperature to what temperature, okay, or how much is the difference in enthalpy. We use this equation. Qgen, heat output from the steam generator in BTU per hour, equal to W, steam flow rate, BTU per hour, power per hour, that we get from the equation, previous equation, right? Multiplied by delta H. I think I should say HS, okay, not to HS. Total heat of steam, BTU per power. We use 1164 BTU per power for 450 F. So if it's come from different value, then we have to use. If it is not 450, you use some other value like 945. Okay, so it's depend on what is the temperature of the steam that we heat it to. Okay, and HW is the heat content of the water returned to the generator. So we use 150 or 148 for 180 F of water. So what happened is you have water, hot water at 180 F. You heat it to make it to become steam. Put steam into a coil. The coil is inside the gun barrel. So this is used to heat the fluid in gun barrel. After it goes to the gun barrel, it come out. It will become colder, right? It become cool water. It's not cold. It's not steam, and it condenses from steam to be hot water, and then you heat it again. Okay, this kind of equation tell you how much do we heat it. If you heat it to 250 F, that H of steam, H sub S, has to be 945 because that is the enthalpy at 250 F. If you heat it to 450 F, if you heat it to 450 F, you have to use 1164 BTU per pound for the enthalpy thing. Okay, in this slide and the previous one, right? Oh, the previous one is the latent heat of steam BTU per pound. Okay, so depending on okay, this I think this one say about constant is a latent heat, is not delta H. So you use about 1000 BTU. So this is total heat required divided by that much will give us pound per hour. So every pound contain about 900 or 945 BTU. Something. Use these two equations together, then we will know how much we have to heat. Should I read more and tell you a question?
Yeah. What's the, I guess, advantage? I feel like heating steam to 450 degrees is going to take a lot of energy. Why would you just like maybe the heater treater use as much heat?
Heater treater is
Heating steam up to 450 degrees.
Heater treater is the direct method. If you can do with direct method, do direct method. If you cannot do with direct method, corrosive, then we have to use this. If it is not corrosive, don't do anything in the gun barrel, just use heater treater. But if it is corrosive, then you may do this to have a lot of retention time and more heat to have the separation. This part is a steam generator table, firebox rating. You have several firebox rating, right? So firebox rating is BTU per hour, that number, okay? And we have working pressure. Look at this. Most of the time it's just 50 psig. Okay, just 50 psig, and that's the bed. Maximum output steam, how many pounds per hour? Okay, so when you select it, you will select it based on that and that. Okay, more information, of course. This one we just briefly go over it. More information is in the syllabus textbook. Okay, good. Do you have this in the exam? If you have this in the homework, then you should have it in the exam. If you don't have this in the homework, probably you don't have it in the exam, but you know where to do it, right? There are several things to test you in addition to this. Okay. Heat loss from vessel. When we heat something, we also have heat loss. Okay. Some heat will just go to the environment. So this is the way we estimate it. QL, heat loss in BTU per pound, BTU per hour will be constant K multiplied by diameter in feet multiplied by shell height, okay, or length of the vessel multiplied by delta T, treating temperature minus ambient temperature. So this will give you a detailed calculation. Okay, so look at this. K. If air doesn't move, K is 9.3. If air move very fast or 20 miles per hour wind, then K go up to 15.7 or something. So if you blow the separator faster, it loses more heat, and that's the amount of heat that is lost to the environment. Then we have to taking into account that and generate a little bit more heat. Okay, if you account for that heat loss. Okay, application. We talked about this one already, but this is a summary for you to read. For example, spherical separator. I know that it's small, but if you actually have the file, you can read it. Spherical separator, see over here, compact, inexpensive, limited use today. So we don't really use it. Okay. Vertical separator, good for fluid stream with low gas oil gas ratio, good at handle high liquid load and slug without carrying over. So advantage and disadvantage, we talked about it already. This kind of summary for you. Next will be corner where you going. You okay? Okay, next one will be size of the droplet. Size of the droplet. So we have several sizes of droplet, 100, 150 to 1 micron. And the left side tells us what method do we use to do the separation. Of course, if you want 1 micron, remove 1 micron plus, we use filtration. If we just 100 and above, we use gravity separation. The rest, if you want 10 micron plus, you use a mist extractor. So this just gives you some summary, okay, for quick check. Very good, ready for homework, right? Use the chart, and if there's steam generator, you will probably open your textbook PDF file and read more. How do we do when we have steam generator? We don't have any equation in the steam generator last year. I may add it. And you know how to do the terminal velocity thing, right? Separation, viscosity, select the size of the heater treater. Done. Question will come a lot after once you have the homework, I think. So when you have homework, even though you have next Wednesday for that, you may try to want to read the homework first and find out which part do you get stuck. Okay. The first step when you get stuck, first step is go through the lecture note. Second step is open your chapter 4. Okay, chapter 4 Silva's textbook. Okay, find out what textbook say. It looks like very thick, but the main text is not many lines. I can tell you. This is just a little bit. You just read it. So once you read it and you still understand, then you go to office hour of him, TA. Okay, you know where his room is. But then you can come to see me if that still doesn't work. Okay, let's do something that you will use for next Wednesday for your project. Okay. Couple students asked me about, okay, what do we do for the tank battery? Where do we choke? Do we choke it at all? Do we use line heater? We don't use line heater or heater. Like, once you learn this, you learn each part of the equipment, right? Okay, now let's put all that together. Satellite and tank battery. Conventional practice, we have satellite cover the radius about 0.5 mile or radius of 1 mile. Okay, and for each satellite you want about 15 to 30 well. Okay, 15 to 30 well. So yeah. So you will have satellite diameter of 1 mile, right? About 1 mile. And inside you have 16 well. Okay. Connect to satellite and you have tank battery. Tank battery should cover the diameter of 6 mile or 4 to 6 mile. So then you have tank battery. So this is 1, 2, 3, 4, 5, 6. So this is the area that covered by your tank battery. So you have several satellites. Okay, several satellites. So each of them cover about 15 to 30 well. You want to do that because 1 month has about 30 days. Okay, 1 month has about 30 days, and you want to test each well 1 time or 1 to 2 times. If you have 15, you can test 2 times. If you have 30, you can test about 1 time. Some months just have 28. Okay, so tank satellite, you can do just header combine them together. So you have satellite. In the satellite can be just header, no separator at all. So if you have just 5 valve, it is better to connect them together and then put everything to the tank battery, right? But in that case, we cannot test each valve separately. So what you do is you have header and you have portable test separator on the trailer. So you have test separator on the trailer and you drive around and test one by one. So each valve you can test at least 1 time per month to find out how much is water, how much solid, how much liquid, okay? If you don't have many valves, if you have many valves but it doesn't produce much, you may decide to have header plus 1 test separator. No actual separator, just a test separator. Once you test it, what do you do? Dump everything together and it go back to the line. So you don't actually separate it, you just test it, how much is each phase, right? So if your line is at 100, so your test separator has to be a little bit above that, maybe 15 psi above the line pressure. So once you test, you have enough pressure to push everything back to the trunk line. Trunk line is the line between the satellite and the main battery. Okay. If you have 15 to 30 valves and you have good production, enough production to afford the cost of the separator. So this time you can have 1 test separator and 1 actual separator, and you separate liquid right there, gas right there. And if you have a gas cell line go across the field like in the middle, so if you have a gas line like that, so you separate over here and then you can sell it right away, right? Depending on where's your cell line, then you can sell it right away. Okay, so if you so that's where we have a lot of production. So the next question is, you see the pressure, the working pressure of the heater treater, right? In the Silva textbook, it's just 75 psig, or sometimes it's 25 and 75. That's 2 models to select. And pressure, working pressure of the vertical separator is just 125. Okay, sometimes it's 1,000 or 500 or something. But valve head can be a couple thousand psi. It can be like 500. Okay. So where do we choke it? Do we have to worry about hydrate? Okay. In your project, I think one of the projects has a lot of water flooding and a lot of oil, right? Okay. Here's the rule of thumb. Okay. Choking and hydrate problem. When it is mostly liquid, don't worry about the hydrate. Okay. JT cooling doesn't do anything, doesn't happen. When you have liquid go through the choke, of course you have pressure drop, but it doesn't cool or do anything. It doesn't have Joule-Thomson cooling. So if you have mostly liquid, you don't worry about it. And if you recall from hydrate presentation, you remember this? Okay, there's a correction factor. You see, this time we produce mostly gas and a little bit of liquid, right? So look at that. If we produce 50 barrel per mmSCF of liquid, we have less temperature drop by 15 Fahrenheit. So this means if you produce mainly liquid, temperature drop, I'm sorry. If you produce mainly liquid, you don't have a temperature drop. Okay. Liquid carry heat with it. When it goes through choke, it doesn't have Joule-Thomson. And on the wellhead, you can choke at the wellhead. Right? It's closing the valve at the wellhead. So wellhead can be used to choke it. So this means you don't need to have a line heater or anything if it is mainly liquid. Okay. So what if you decide, okay, you want to use a satellite and you produce a lot and you have one satellite with you have one satellite. Oh, that's my picture. You have one satellite, and in that satellite you have header, you have separator, test separator, and you try to sell gas. And what about those liquid? The liquid from the separator, it will. What temperature do we set? Okay, that's the question. Okay, look at this one. So if you have a well pressure of 500 psi, for example, that's the well pressure, right? And we know that separator working pressure is 125. Don't go exceed it. Okay, you may set pressure relief valve at 120. That is pressure relief valve. So it won't go above 125. So when you have pressure from the well at 500 psi, you will ask how long will that produce at a quick rate? Will it be like 3 months, 2 weeks, or 5 months, 6 months? So what you can do is you use the well, close it a little bit, and you set it at 120. So when you choke the well a little bit at 120, once it reach, okay, 500 psi. If you have some gas, do we worry about hydrate? Probably not. Okay, why is that? Look at this chart. Hydrate thing. Okay. So this chart may can give you some idea about where you have hydrate, right? If you have 500, so it should be very, very hot. Okay, so you don't really form hydrate. When it comes from the well, it is hot, right? It's still hot. 130, 140 or something is still hot. It carries heat from the reservoir. So when it is at the wellhead, you can just choke it over there. And it won't form hydrate because liquid, when it goes through choke, it doesn't have JT cooling. And you are low pressure already. It requires your ambient temperature is not cold enough to produce hydrate. Okay? If you want a more accurate, this chart gives you a enthalpy difference, but if you want accurate hydrate temperature, you may not be able to read from that chart. You read from this chart. So if you are at 500, let's take a look at 500. So 500, and you produce specific gravity of let's say you produce mainly methane and a little bit, so maybe 0.65. So your phase envelope may be over here. So it has to be that cold, maybe 44 Fahrenheit or something to produce hydrate. And your ambient temperature could be cold enough. In winter, what do? You bury the pipe, heat trace it, and insulate it. Okay. What is that about? Okay, let me explain more. What you want to say is, look at this one. When we produce any water or do water flooding, you don't worry much about hydrate either. Water carry more heat than oil. Okay, and when it go through any restriction, it doesn't do any JT cooling. Okay. When it is already low pressure well, you don't worry about hydrate because you're probably outside the hydrate envelope. Of course, sometimes, let's say hydrate temperature is at 60. Okay, sometimes you go below 60 and you may worry that you have hydrate, right? But probably not if you keep it flowing. You bury the pipe. So look at this. Bury the pipe below the frost line. Okay, below 18 inches or 2 feet. If you bury the pipe, and the part that is above the pipe, you use a coil, heat trace it, okay, and then insulate it. Then you will be fine. Okay. Bury the pipe. The pipe, your wellhead, look like this, right? Some part is above ground. So this ground level, you go underneath it. Okay, buried it. And the part that is above, put the heat trace. It's a coil that when you turn it on, it's have a thermostat. When it's cool, it's on. So it uses the power from the grid. And you insulate it. You put the insulation wrap around this part. So the part over here, you don't have any problem. The pressure is low enough and you keep it flowing. Okay. So if you have like 500 psi, probably you won't have, especially if you produce a lot of water, because water carry temperature with it, right? Okay. And when you bury it, during the winter, if the temperature drop, you may not have 100, but you may have ice. Okay. So if you have ice, it's block the pipe. If it's too bad, it may be burst the pipe and the pipe may leak. You don't want that, right? So you just bury the pipe below the frost line and let it flow. If it keeps flowing, you don't have problem. Look at the pressure. Seawalls have 230, 500, 1200, 1440, 1500 working pressure separator. Several of them, right? I give you just one example of setup. You may set you may choke at the well a little bit, just close the valve a little bit, and it come in at 500, but it come out at 120. At a certain distance, when it flow, there will be some pressure drop, so it maybe go from 120 to 115 psi. When it is 115 psi, you have a back pressure valve. So back pressure valve set at maybe 115. So if it is above 115, gas can come out. If it is below, it's accumulating here, right? Okay. And then you go to another separator. So this is 75 working pressure for the heater treater. And you don't want to go exceed 75. So in this tank is 115, right? When it is 115, pressure is high enough to push liquid from one tank to another tank. So the dump valve open, right? You have the float and the dump valve open. Whenever dump valve open, liquid go to this tank. Okay. When liquid go to this tank, if the liquid level is too much, this dump valve will also open and it will go. So that one close and then this one will close. So you have enough pressure. You don't use any electricity, you see. You have enough pressure to push from one tank to another tank. Okay. And you have a back pressure valve regulate at 65. So below 65, gas cannot escape. Above 65, it goes to the cell line. And the cell line has to be pressure less than 65, maybe 50 psi. And that cell line pressure is always in the contract. Okay. If you have cell line of 300, then you cannot sell the gas, right? You have to have a compressor. Okay. Gas compressor that we are about to talk about. So when we gather from several satellites to main battery, that line from the satellite to main battery is a trunk line, and this part we call gathering system for the facility operator, right? Once you have our gas will go to gas plant, probably 10 miles away. So gas go from battery to gas plant. Gas plant process it and then go through 2,000 miles to New York or maybe go to New Mexico and then from Mexico to California. So it's go to cross-country pipeline, a bigger one. Okay, so this should give you enough. Do you want to talk more about this? Question for Dennis, Mr. Bullard. Question for him. Okay, question for him? Oh, okay. Yes.
I got a question. So, a few slides ago, we were talking about if we had 15 to like 30 wells and having a test separator. But if you only have 5 wells, you're saying you bring like a portable test separator? Is that actually common?
In New Mexico or?
portable test separators are used if you're tying several smaller wells and you want to put them through a header, then portable test separators can be taken to the wellhead and test the well there. If you just have a few wells, you don't have that header distance to worry about, you're not using satellites, you take those to the well, all those individual wells, to the battery, build a header there, and then go to a test vessel. So a portable test separator is kind of last resort. And these distances that we give you there are kind of like rules of thumb. They'll vary with topography, they'll vary with the volumes of wells, or the volume of wells that you have, the type wells that you have. But those are generally how you would size where you put your headers, where you put your remote satellites. And it's a cost trade-out because those pipelines from the satellites to the battery are bigger pipe, they're more expensive. But it's got to trade out against the cost of running all those individual lines all the way from a well a mile away to a battery to a smaller line. And it's all nodal analysis. If you put more back pressure at those batteries or satellites because you use smaller lines, then you've decreased the productivity of the well. So you want to lower that wellhead pressure all you can. There's a trade-out between that pressure you can achieve and what the cost is to lay the pipe to get there. Good.
More question, more question.
In my first summer internship, it seemed that a lot of our wells were new wells, but it seemed like we had one training for one well. We didn't do multiple wells into one separation chamber. Is that common initially, or is that something that company just did?
They did that because they're in a hurry. And they get time value that money, and so they have design trains. A lot of companies do that, where they'll just put that one well in there. It's a high volume well, but it falls off pretty quickly.
Yeah, they had like we had a battery that had like 8 wells, and they all had their own separation chamber and everything.
I can show you one's got 16.
Yeah, like
And so as they fall off, the wells fall off, they can put the well back here on this first one, it's falling off enough to connect their facility to it. Ultimately, they keep falling off enough, they can just take those out like units, ship them to the next place where they're going to do well. But yeah, if we had time to think about it, order the equipment all ahead of time to know exactly how much production we were going to come in there. We build big tanks, big separators, like an offshore facility and the deep water facilities. They wait years from the time they drill the well until they put it on first production, because they're building a facility to handle what they know ultimately will come in there. Onshore, different mindset.
Oh, project. You do part of your project, you will submit for my class, right? What I want from your project is about 300 to 500 words per page and about 10 pages or more. Okay? It is, if you have very thick, it doesn't mean that you did a lot. Okay? If you have very thick, it doesn't mean you did a lot. But if you have half a page, it doesn't mean you didn't do anything. Okay? So thickness cannot tell that you work or not, but if it's thin, this means you didn't work. Okay? That's very clear. So what I want from my part, I want about 10 pages. So 300 to 500 words per page for 10 pages or more. So at least you will have about 3,000 words. 3,000 words is not a lot. You will show me, of course, you have the summary in the front, and you will show me calculation example. I need to see equation that you put. And I need to see how do you substitute the value. I know that you do that for many cases. You show one case. Okay? You have to show something about equation. I have to see, when I look at your report, I have to see equation. That's what I want to see. Equation, how you substitute the value, what equation do you use. And next, you show me, you give me the proof that you actually do the work. Okay? I cannot check all your Excel